Before we move on to analyze attacks on the second OSI layer, we have to explain one more thing. There are two kinds of devices operating in the link layer. These are hubs and switches. Hubs are still in use, though they're getting less and less popular. They differ in that they pass on the frames that they receive. When a hub receives a frame, it will get forwarded through all ports. This is called broadcast. In this case, everyone can receive the frame. But obviously, the only receiver should be the network card that the frame was addressed to. On the other hand, a switch would forward the frame through a port connected to the host identified by the MAC address appearing in the frame. Someone may ask, how does a switch know which port a given host is connected to? This is not part of a switch initial configuration. A switch learns which hosts are connected to which ports. If it doesn't have that information, it forwards incoming packets to all hosts that are connected to it. Only one of them should give a response message. Only one port should actually receive the packet. This is how the switch learns that a computer identified by the MAC address ending in 09 is connected to the port number 12. This information is then stored in the CAM memory. It's an associative memory. In contrary to address-based memories such as RAM, CAM is a content-based memory. As a consequence, a switch can work like a hub. This is how it works right after the first startup. It can also be changed to the hub mode by an attacker. Almost every network is based on switches. You won't be able to intercept data sent between hosts just by connecting to the medium. Because of the mechanism we've just described, you won't get data that's not addressed specifically to your machine. The port your computer uses won't get any needless signals. This problem is typical of wired networks. It's not present in wireless networks. In wireless networking, all users share the same medium. Therefore, attacks on wireless networks don't require the attacker to perform all the operations we're about to discuss, such as poisoning a victim's ARP cache. The first way to intercept traffic in a wired network is to change the switch configuration. It must be forced into hub mode. One way to implement this kind of attack is by using a program called makeoff. The program floods switches with random IP addresses with attached MAC addresses. The switch must remember all of them. Usually, users buy cheap switches, so it may be expected that the device's CAM memory will shortly be full. Then it will no longer be able to remember which host connected to which port. How the switch will react depends on a specific model. Some models go into the hub mode. They broadcast the packets, which ensures that the network won't go down. Newer models usually block the port that receives the flood of random IP and MAC addresses. Still, others just crash. Switch manufacturers reacted to the threat coming from the makeoff program. Therefore, a new version of the program was created. This time it uses only IP addresses from the local network. Switch flooding is, however, not very effective. It depends on something that the attacker doesn't control: the switch reaction. It's also a very noisy method. It may end up as a DOS attack affecting the whole company. A typical company network has a hierarchical structure. The first flooded switch starts broadcasting packets everywhere, even through the uplink port, which sends them upward in the hierarchy. This may lead to the flooding of the whole network, which would obviously prevent you from intercepting any meaningful network traffic. Therefore, another frequent attack consists of ARP cache poisoning. The ARP, or Address Resolution Protocol, is responsible for IP and MAC address mapping. When you want to connect to a host, you don't use its MAC address, but either its IP or its name. A mechanism must exist that would change the IP you type to the MAC address, and it's done through broadcasting. If a computer learns that a MAC address ending in 09 corresponds to a machine identified with an IP address ending in 12, it will save this information. The information will be saved in the ARP cache buffer. After that, whenever your computer will try to establish a connection with the machine of a given IP, it will send packets to the MAC address saved in the buffer.